Okay, so we'll cover some basic aspects on the chapter of polynomials, and this is the part 1 of this chapter. And within this, we will discuss some first revise some basic concepts of what is a function and what are the types of polynomials. We'll also see the division of polynomial, and within that, we will see the application of remainder versus the factor theorem. And we'll also have a look on some useful identities. We will see what is a homogeneous expression and what is a symmetric or cyclic expression. And finally, we will see the Horner's method of synthetic division for factorization. So what is a function? So function can be treated as a machine, okay, which takes an input of one value. This value can be treated as x, does some calculations with the machine. So here we can consider or imagine the equation, okay, and provides an output accordingly. Okay, so in algebra we can see that functions relate one variable to the other in the form of equation. Okay, let's take an example. So for example, we can see that y is equal to 2x. Okay, so for one value of x, we get a particular value of y. So this y is equal to 2x is a function of x. So if you, for example, consider x is equal to 1, then the value of y will be 2 into 1, which is equal to 2, right? Similarly, if we consider x is equal to 2, okay, so we provide an input of 2, you get an output of 2 times 2, that is 4. So similarly, if you put x is equal to 3, you know that the function of x or y will be equal to 6 because y is equal to 2x. Okay, so for every value of y, for whatever input you put, you get a particular output. So one member of the input set relates to one member of the output set. This is very important. So one important thing you should know that, for example, just now we learned this example, y is equal to 2x. So this is a function. Why? Because I just now told that one member of the output set relates to one member of the input set, which is x. Okay, but think of this example, y square is equal to x. Okay, so y is the output and x is the input. So for one member of, for example, 2, you provide 2 times 2 for one member of 2. So the value of output will be 4. But if you provide x or input as minus 2, then also the output will be 4. Okay, so the input set have two members, right? So 2 and minus 2 relates to the output set 4. So we cannot say that y square is equal to 2x is a function. So this is one important thing that you should know, that one member of input set corresponds to one member of the output set, and then only we call it as a function. So just now we just revised the concept that for one member of input there cannot be many outputs. So that is not a function. Also functions can be represented graphically. The example that we just now have seen is a linear function, but we will see simultaneously that they can be quadratic, they can be cubic function, they can be trigonometric function. So these are examples of the functions. That means one member of input set corresponds to one member of the output set. So for example, very important, you should know that this fx does not mean that it is f times x. It is a function of x. That means function of the input will be equal to the output. Most common, we can write fx is equal to y. It doesn't mean that we will write only f. It can be in the form of gx is equal to y, or ha is equal to y, or b, whatever. So this letters doesn't represent anything. This is not a multiplication. These are only the set of equation. So you have to consider in that way. Also, just now we have that example that fx is equal to 3x plus 2. Let's take this example. So f4 will be 3 times 4 plus 2, that is 14, right? So this is a function because for every value of input we get a particular value of output. So very importantly, this input have another name of, we call it as input set, we call it as domain, and the output set we call it as range. These are only terms or the words that you should know, that don't get confused whenever you use this word in a question or you see this word in a question. Okay, now a function fx of the form this where fx is equal to a0 plus a1x plus a2x square etc. to an xn. If you see this particular function, we call this a as coefficient, right? a0, a1, a2, an, we call it as coefficient, and x is called the variable, right? And this is the degree. So these are the real numbers. So consider a function of this particular formula, and where these coefficients are the real numbers and n is a non-negative number, okay, then it is called a polynomial in x. So this is the definition of polynomial. So for example, we write x to the power minus 1, that is a1 divided by x. So instead of x to the power 1, we replace it to x to the power minus 1. Then this expression will not be a polynomial. So in order to be a polynomial, the degrees or the powers has to be positive. Okay. And this has to be a real number like a0, a1, a2 and so on. So for example, 6x squared plus minus 8x plus 5 is a polynomial with integral coefficients. Means the coefficients are integers like 6, minus 8 and 5, right? 5 is x to the power 0, right? This is x to the power 1, this is x squared. So this is a polynomial because all the powers of x are from 0 to positive numbers, they are not negative numbers, and this is also a real number coefficient because 6, minus 8 and 5 are real numbers. Similarly, this is also a polynomial. Why? Because here if you see, the powers of x is 3, 2 and again 0. Nothing is there, that means we can think that it is 8 into x to the power 0. That means the powers are 3, 2 and 0, which is not non-negative. And also the coefficients are real numbers, they are rational numbers here, right? So this is also a polynomial. This is also a polynomial like 6, if you see that 6x to the power 4, x squared and x to the power 0. So the powers of x are non-negative. So you can recognize which numbers are or which expressions are polynomials and which expressions are not polynomials. Okay. Now the types of polynomial, you already know that, right? If there is only one term in the expression, we call it as monomial. If there are two terms, we call it as binomial. If there are three terms like this is one term, this is one term and this is one term, we call it as trinomial. And if there are four terms, we call it as polynomial. So if there are more than three terms, we call it as polynomial. Okay. Now coming to the degree of polynomial. So what is degree? So the degree is the highest sum of the exponents for any one monomial of the polynomial. So highest sum of the exponents for any one monomial. What does it mean? For example, how many terms are there? We can think that there are two terms, right? So it is a binomial. And what is the degree of this particular set of binomial? It is only 1, right? And what is the degree of this one? We can think of x to the power 0. So this is 1 and this is 0. So what should be the degree then? It should be a degree 1, right? This one. Similarly, consider this expression So how many terms are there? There are 3 terms, right? So it's a trinomial. So and hence for the first term it has a degree of 3, for the second term it has a degree of 1, and for the third term it has a degree of 0, right? So the highest degree is 3, so it is a degree 3. Got it? Similarly, for the last example, here there are 3 terms again, so it's a trinomial. And for the first term, what is the degree? So we can think of 2 variables. Here there are 2 variables, so it will be a sum of exponents, right? So it is a 3 plus 1, right? So this degree is 4, this term's degree is 4, this term's degree is 3, 1 plus 2, that is 3, right? And this term's degree is 0. So highest is 4, so the degree will be 4. Got it? Okay. Now coming to the division of polynomial. So what is division of polynomial by another polynomial? Like if fx and gx are 2 functions and they are 2 polynomials where gx is not equal to 0, this gx is not equal to 0, such that fx is equal to gx times qx, qx is another function, plus rx, okay, where degree of rx is less than degree of fx. So consider this expression fx is equal to gx times qx plus rx, and the condition is that this rx degree should be less than fx, okay. Then when so if this condition fulfills and we divide fx by gx, so we divide fx divided by gx, it gives quotient as qx. So here qx will be the quotient and rx will be the remainder. Now what will happen if this condition, that is rx equal to 0? So remainder, what will happen if remainder is 0? That means we can say that the divisor, which is the divisor? The gx is the divisor, right? So gx is a factor of fx. So consider a simple example like 6, right? So 6 divided by 2 is 3. So we can write 6 is equal to 2 times 3, right? Plus 0. So if remainder is 0, then 2 is a factor of 6 or 3 is a factor of 6, right? So this is only the condition that remainder has to be a 0 in order to be a factor. So now we can divide this part into two theorems that we have already learned in your school. So one is the remainder theorem, right? And one is the factor theorem. We will do some questions related to this, but just a revision, but that is related to the theorem. So when it will be a factor, like when rx equal to 0, right? Now we will also use some useful identities. I will advise you can note it down in your notebook, but just a revision. So a plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. We can also represent a minus b and a plus b with the help of minus 4ab. So these are identities that you should learn by heart because that's very, very useful in factorization process. Okay. Similarly, this one is also very, very important, like a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c times a square plus b square plus c square minus ab minus ca minus bc. Okay, so all these equations or identities should be learned by heart. Now, important note is that when a polynomial fx is divided by this expression, that is x minus a and x minus b together, the respective remainders are a and b. So when fx is divided by x minus a, the remainder is capital A. When fx is divided by x minus b, the remainder is capital B. Okay, so this is the condition, given condition. And then if the same polynomial fx is divided by the product of x minus a times x minus b, then the remainder will be this equation. So this is derived, but this expression may also be useful in solving some problems. Okay, so a minus b, this is the remainder. So a minus b divided by small a minus small b times x plus ba minus ab by a minus b. Okay. Now what is homogeneous expression?
Okay, now what is cyclic expression? Cyclic expressions are those algebraic expressions where some conditions fulfilled. For example, an algebraic expression of functions f, x, y, z, where there are three variables, okay, which is x, y, and z, is called cyclic if function of x, y, and z is same as function of y, z, and x, and which is same as f of z, x, and y. What does it mean? That is, if x is replaced by y is replaced by z, and z is replaced by x, both values should be same. The output should be same. Similarly, y is replaced by z, z is replaced by x, and x is replaced by y, the value should be same. Now, very important, you should note the sequence of x, y, and z. So, if it is x, y, z, then it is the next the other function should be x, y, and z. So, it is in sequence to y, z, x, y, z, x, and then z, x, y, which you can also read it as x, y, and z. You cannot just randomly choose, okay? So the sequence has to be x, y, z. Here it is y, z, x, and then z, x, y. Let's study with an example. So if this is an example where you can see function of a, b, c, okay, is same as function of a, b, c is a of b minus c plus b of c minus a plus c of a minus b. This is an example. So what is our rule? We are interchanging the variables. So we will replace a with b, b with c, and c with a. So a, b, c, a, b, c, here a, b, c. So we have to see that they are equal or not. So we will replace a with b. So instead of a, we will write b. Instead of b, we will write what? C, right? And instead of c, we will write a, right? But we will write b. Instead of b, we will write c, right? Instead of c, we will write a. So it is a minus. Instead of a, we will write b plus. Instead of c, we will write a, right? Instead of a, we'll write b, and instead of b, we'll write b. So if you see, this one is the function. Now we will do the other one. So here we'll write I will replace b with c, c with a with b. Okay. So instead of b, I should write c, right? And then instead of c, I should write a. And instead of a, I should write b. Right? This way we will do. Instead of c, again we will write a. Instead of a, we will write b. Instead of b, we will write c. Plus, instead of a, we will write b. Instead of b, we will write c. Instead of c, we will write a. Now we are going to compare. Okay. So here it is b into c minus a. Here if you see, this term is there, this term is there, and b into c minus. So here b into c minus a term is there in the three expressions. Similarly, c into a minus b, if you see here, this here, c into a minus b, and c into a minus b. Okay, and similarly if you see the other one, a into b minus c, a into b minus c, a into b minus c. So all these three terms, f of a b c, f of b c a, and f of c a b are equal. So this is called a cyclic expression. So this is an example of cyclic expression. This is how we check. Okay. Now another thing you need to know is that about some notations. So this notation is called sigma, and this sigma is used for the sum of the terms of a cyclic expression. Okay. So for example, sigma of x, y, z, we can write it like this: x cube of y minus z is the same. If we write sigma of x, y, z of x cube of y minus z, then it will mean that it is x cube of y minus z plus y cube of z minus x plus z cube of x minus z. The cyclic expression. So even if we don't write the right hand side, and simply if we write this symbol sigma, it implies that it is a cyclic expression, and we can convert the cyclic expression to the RHS format or right hand side format. Okay. Similarly, another symbol is the pi. So pi is used for the product of the terms of the cyclic expression. So sigma is used for the sum and pi is used for the product. So pi of ABC of a minus b is same as a minus b into b minus times b minus c times c minus a. So remember that a is replaced by b in the second term and b is replaced by c in the third term. Okay. So this is how the cyclic expression is.
So if all the terms of the algebraic expression are of the same degree, then such expression we call it as homogeneous expression. Let's see an example. So the homogeneous expression of xy, for example, here we have of degree 1. So this is a binomial, right? And here this one, the first term has a degree 1 and the second term also have a degree 1. So it is a homogeneous. So all the algebraic expression where all the terms have the same degrees, so we call it as homogeneous. For example, the second example, this is px square plus rxy plus qy square. So p, r and q are coefficients, okay, and for the first term the degree is 2, for the second one it is 1 plus 1, that is 2, and for the third term also it is 2, so it is homogeneous. Similarly, for the third example, if you can see here, the px cube plus rx square y plus sxy square plus qy cube, where p, r, s and q are coefficients, and for the first term the highest coefficient is 3, for the second term the sum of the highest coefficients will be 2 plus 1, that is 3. Similarly, for the third term it is 3, and for the fourth term also the power or the exponent is 3, and hence it's also an homogeneous. Okay, so we can identify which expression is a homogeneous and which is a not homogeneous. Now coming to the symmetric expression. So what is symmetric expression? An algebraic expression fxy in two variables xy is called symmetric expression if f of xy is same as f of yx. Let's see an example. So if you see this example, f of xy is equal to ax plus b plus ay. So this is input, so this one is input and this is the output, that is xy. Okay, and here the variables are x and y, coefficients are a and a also here, and this is the b is a constant. Okay, so now we will interchange the variables. So we will write here interchange the variables. Okay, so f of xy is ax plus b plus ay. Now I will interchange with, for example, f of yx, right? So f of yx will be x is replaced by y and y is replaced by x. So here I will, instead of x, I will write a of y plus b plus, here it is a of x. Now if you see here, this one, this is f of xy, okay, and this is f of yx. So both are same. So ax plus b plus ay and ay plus b is plus ax is same as, is they both are same by associative law of addition, right? So we can say that in this particular example, f of xy is equal to f of yx. So in this example we call it as symmetric expression. Okay, so we can identify which expressions are symmetric and which are not. Got it? Okay, so now the last section of today's session is Horner's method of synthetic division. It's a method of division, of course, and here the step 1 is we have to write the coefficients in descending order. Okay, so the coefficients of the descending powers of the variable in the first row. Descending means the largest one is in the beginning and the lowest one at the last. So I will provide one example where you can understand it better. Then we have to calculate the multiplier, and multiplier is calculated with the help of the divisor function. Divisor means, for example, if you divide 6 divided by 2, that means 2 is the divisor, okay, and 6 is the dividend. Let's look into this example. So this is the function, okay, 3x cube minus 2x square minus 19x plus 22, and the divisor is here x plus 2. So first step, as I told, that we have to see the powers of the variable. Here the powers of the variable are already arranged in decreasing order. So the 3 is the highest power, then 2, then 1, and then there is it's a constant term 22, that means x to the power 0. So the arrangement is already done. The next step is we have to calculate the multiplier. Okay, so the multiplier is, we will calculate the multiplier. Okay, multiplier, that means from the divisor. Here the divisor is x minus 2. So we'll calculate x minus 2 equal to 0. That means x equal to 2. Got it? So this is the first step. Now the second step is we have to see the coefficient. So here this is the coefficient. So 3 is the coefficient of first term, minus 2 is the coefficient of the second term, minus 19 for the third term, and 22 is a constant term, but we'll write it. So let's make a big L, okay, and within the L we'll write the coefficients where it is already arranged. So we'll write it first as 3, right, and then the coefficient is minus 2, then minus 19, and finally 22. Okay, and we have calculated the multiplier as 2. X is equal to 2. So we'll write the multiplier as 2. Okay, so we'll write it as multiplier. Now we will write it here as 0. Okay, so for the first term we can write it like this. So 3 plus 0 is, what is 3 plus 0? It is 3, right? And then we will multiply it with 2. So the multiplier is, we know the multiplier as 2, right? So we'll just simply multiply this term that is the after the addition we have got 3, right? So 3 times 2 is, we are getting as 6. So we will write it here as 6. Okay. So what is the addition of these two terms? 6 minus 2. So here we have done 3 plus 0 is 3. So what is 6 minus 2? It is 4, right? And here we will again use the multiplier option, and we will multiply again with the help of 2 multiplied by 2, right? And here we get as 4 times 2 is 8. Okay, and here we again do the addition, right? Addition. So minus 19 plus 8 is minus 11. Okay, and we again do the multiplier. That means we are multiplying it with times 2. 11 times 2 is what? It is 22. Now 22 minus 22 is 0. And this 0 is the remainder. So this 0 is the remainder. Okay. So whatever we have got here, that is 3, 4 and minus 11, they are the coefficients of the quotient. And so we will write the answer as, that is the quotient. Quotient will be equal to 3 of, so our question was x cubed, so it should start from x squared. So it should be in an order. So 3x squared plus 4x minus 11. So this is the quotient that you have got. Okay. And this is the remainder. So this is way we can use the Horner's method of synthetic division, and it will shorten your time. So we have learned this method more and more for shortening our time in competitive examinations. Okay, thank you.